Good evening, sir.
Yeah, good evening, Abhinav.
Good evening, sir.
Good evening, sir.
Yeah, good evening. Just keep joining.
Yeah. Good evening, sir.
Yeah, good evening.
Good evening, sir.
Good evening. Yes, sir. So I think we have completed metals and non-metals. All right. Today we'll do just question answers from that chapter, metals and non-metals, and then later on we'll move. Tomorrow we'll move on to the new chapter. Got it? मेरा भी तबीयत ठीक नहीं बेटा चलेंगे कुछ पैर से भी चल नहीं पा मम्मी का तबीयत ठीक नहीं अभी जाऊंगा सुबह Okay, so let's start with question answers of metals and non-metals. We have I think it's 21 pages book. Okay, so we are here at the question answer. See, which of the following pairs will give displacement reactions? So, Shubhansh. Shubhansh,
Yes, sir.
yeah, which one of the pairs will give displacement reaction?
Sir, it will be NS. Now, sir, a second. Sir, the second one.
Second one,
Yes,
No.
sir.
can aluminium replace magnesium?
Yes, sir.
Aluminium cannot replace magnesium. Aluminium is less reactive than magnesium.
Sir, the option is D.
Yeah, it's the last option, silver nitrate. Silver can be replaced by copper metal. Copper is more reactive than silver. Okay, so it's the last option. Then which of the following methods is suitable for preventing an iron frying pan from rusting?
Sir, I think option C.
Option?
C.
Okay. Aryan, can't it be option A?
Sir, which question are we doing again?
Question 2.
Option C, right?
Okay. Why not option A? Why not option B? Whereas
Because
we
it's
have
a
learned
frying pan.
that applying grease and applying paint, it also helps in preventing corruption.
Sir, because it's a frying pan, right? So we hate grease and paint, which we stick to our food.
Yeah. What will happen? I don't know.
It will stick to our food as we are applying heat on the pan.
It will
Stick to our food because it's a pan.
it will start burning.
Yes.
Grease and paint can burn. So it can start burning. All right. Okay. An element react with oxygen to give compound with a high melting point. The compound is also soluble in water. The element is likely to be.
Sir, calcium.
Why calcium? What are the reasons that you give for it?
Sir, because it will combine with oxygen to give CaO, calcium oxide.
Okay, so how do you justify that calcium oxide will have the given properties?
Sir, because it will release it have high melting point and it will dissolve in
But
water.
how do you know it has high melting points?
So, sir, can you repeat?
Yeah.
Sir, can you repeat?
How do you know that it has a high melting point?
Sir, because it takes much time to burn.
It takes much time to burn. Mm-mm. But and you haven't learned it anywhere burning of calcium oxide. Yes. Moksha,
Yes,
give
sir.
any suitable reasons by which we can justify that yes, calcium oxide is the thing that we are searching. See, calcium forms ionic bond with oxygen, whereas carbon and silicon they form covalent bond. All right, and hence calcium oxide, which is the required metal. Even iron can be there, but iron has low reactivity as compared with calcium. All right, so therefore it is sure that it is calcium oxide. Got it? And then food cans are coated with tin and not with zinc because why tin and not zinc? Okay, what is the difference between tin and zinc?
Sir, may I?
Yes.
Sir, tin and zinc can react with organic acids.
Okay, and while organic acids. Okay,
Yes, sir.
and tin cannot. Is it?
Option C, zinc is more reactive than tin.
Yeah, it's option C. Zinc is more reactive than tin. All right. You are given a hammer, a battery, a bulb, wires, and a switch. How would you use them to distinguish between samples of metals and non-metals? Okay. So how will you use a hammer?
Test
Yes.
to test malleability and ductility.
Yeah. Okay, what will happen if you apply a force by a hammer?
Sir, metals will transfer into thin sheets while non-metals
Flat,
will not.
and
What will happen?
if you hit
Sir,
them, they become flat. So which shows that they can be molded in thin sheets.
Okay, so if it is a metal, so it will get deformed into its shape. Whereas if it's a non-metal, it will get broken. It is brittle, non-metals are brittle, so they will get broken apart. So we can test it using a hammer. Then how will test with the battery, bulb, wire, and switch?
To check this electric conductivity, metals conduct electricity while non-metals do.
Yes. Then this one. What are amphoteric oxides? What are amphoteric oxides?
Sir,
Which are
may I?
reactive by both acids and bases.
They include both.
Acids and bases. Give out the respective forms.
Okay. So Abhinav, no, Dharya,
Yes, sir.
what are amphoteric oxides? Give me the examples.
I don't remember, sir.
See, we had seen ampho means sphere. So amphoteric oxides, the oxides which may show acidic as well as basic behavior, they are called as amphoteric oxides. So there are certain oxides which
Sir,
show,
which behave both like acids and bases.
yeah, so they react with an acid to show neutralization reaction, and they also react with strong bases to show neutralization reaction. So such oxides, they are called as amphoteric oxides. Can you give an example for this?
Sir, zinc
Sir,
oxide and iodine.
Al2O3, aluminum oxide.
Aluminium.
Oxide.
Any other? Any
Zinc
other?
oxide, sir.
Zinc oxide. All right. So aluminum oxide and zinc oxide, they are the two amphoteric oxides. Name two metals which will displace hydrogen from dilute acids, and two metals which will not. So which are the two metals
Sir, may I?
that will displace hydrogen?
Sir, sodium and magnesium.
Okay. Sodium, magnesium, and which one do not displace?
Silver, copper.
Which one?
Copper.
Copper, silver, gold.
Gold.
All right. In the electrolytic refining of a metal, in electrolytic refining of a metal M, what would you take as the uh, anode and the cathode and the electrolyte? Sumukh,
Yes, sir.
yeah, which substance will you take as anode and which substance will you take as cathode? Remember, we had done that one of the electrodes is taken as a positive electrode, the other one is taken as a negative electrode. So which one is taken as a positive electrode?
Sir, anode.
Anode. So what do we make anode? Do we make it by pure metal or impure metal?
So pure metal.
No, anode is made with the impure metal, and that is why we call the particles which are collected below that to be anode mud. I hope you remember what is anode mud. So here, what substances will be taking? We'll be taking impure rod of metal M to be the anode, pure rod of metal M to be the cathode, And what should we choose as the electrolyte?
Sir, aqueous solution of salt of the metal M.
Yeah,
Aqueous solution of a salt of the metal M.
yeah, aqueous solution of the salt of metal M. Alright. See, reason Pratyush took sulfur powder on a spatula and heated it. He collected the gas evolved by inverting a test tube over it, as shown in figure. What will be the action of gas on dry litmus? So what will be the action of this gas on dry litmus?
Sir, no change in color will take place.
No changing. In the first case, there will not be any change on the dry litmus paper, as its acids and substances, they show their test when they are aqueous. What about the second one for the moist litmus?
Sir, it will change red as sulfur is non-metal. It will oxide.
It will.
Sir, it oxides are acid in nature. It will change red.
So it will change. But which acid will be changed to which color?
The sulfur will change to red.
Hmm?
Sulfur will change to red as it is non-metal.
No, I think still you are not clear. Which litmus paper you are using, you have to state that. And what is the product you are getting?
Sir, the moist blue litmus paper will change its color to red because
Yes, yes.
uh,
Since the gas,
sulfur is non-metal.
okay, what is the gas collected here? Which gas is collected here?
Don't know.
When you heat sulfur powder in air, it forms sulfur dioxide gas.
Sir, sulfur dioxide and trioxide, sir. Sulfur.
Yeah, sulfur dioxide and sulfur trioxide. So these gases, when react with moist litmus paper, so they show their acidic behavior, and hence you'll find blue moist litmus paper turn to red. Then write a balanced chemical equation for the reaction taking. So all of you write down the balanced chemical reaction. Wonderful. Yeah. So is there anyone whose reaction is ready?
Sir, mine.
Okay. Just balance your reaction also.
Sir, balance those.
Okay. So show it.
Sir, can I speak? My camera is not working.
Okay, you can share the picture.
Sir, on WhatsApp?
Yeah, either on WhatsApp or in the okay, just share in the WhatsApp only.
Okay, sir.
Okay, all right. Instead of taking so much of time, it will take so much of time. Let me write down the reaction over here only. The reaction is you have to write S. First, we have sulfur plus oxygen reacting to form sulfur dioxide gas. The second reaction you write as sulfur plus oxygen reacting to form sulfur trioxide gas, SO3. Balance both the reactions. So for the first one, you get here 2 SO3, so 2 sulfur and 3 oxygen. The second one we get the reaction already to balanced. Then we write sulfur dioxide reacting with water to form sulfurous acid H2SO3 and SO3 reacting with water to form sulfuric acid H2SO4. Next one. State 2 ways to prevent the rusting of iron. Okay, so Arav,
Sir, by painting or greasing the surface of iron, or sir, by galvanization the iron surface.
by galvanization or by,
Painting or greasing the surface of iron.
okay. So these are the methods you pay by painting. You have to prevent the rusting of iron. So painting or galvanization, oiling, these are the methods of preventing the rusting of iron. What type of oxides are found when non-metals combined with oxygen? So generally what type of oxides are found? Huria Ishaq? Yeah, Huria Ishaq, what type of oxides are found? Aryan?
Yes,
Aryan?
sir. Yes, sir.
Yeah, what type of oxides are found?
Acidic oxides.
Acidic oxide, very good. The oxides of non-metals are acidic in nature. So you have the formation of acidic oxides. Okay, the last one, not the last, this is question 12. Platinum, gold and silver are used to make jewelry. Why? Then why do we use platinum, gold and silver to make jewelry?
Sir, they are highly malleable.
No, we have other also available. We have aluminium also malleable. So then
Luster
Sir,
is also,
they are lustrous,
yes, sir.
right? They are
sir, they are
lustrous
less
and they are very
reactive.
less reactive. Okay, they are very less reactive. So they do not lose their luster very often. They can retain their luster for a long duration. Right? Then sodium, potassium, and lithium are stored under oil. Why? Why sodium, potassium, and lithium are stored under oil?
Because they would react vigorously with air.
Moist and oxygen, sir.
Yeah, they react vigorously. They react vigorously when come in contact with air or moisture. Then aluminum is a highly reactive metal, yet it is used to make utensils for cooking. Why? Yes. Why do we use it aluminum for making?
Don't know, sir.
Not known.
Yes.
So first of all, the oxides of aluminium. All right. Oxides of aluminium, they are insoluble in water. Okay. So that is why it is used to make utensils. It is a good conductor of heat, and hence it can be used. It can be used for making utensils. Carbonate and sulfide ores are usually converted into oxides during the process of extraction. So why do we them convert them to their oxides? See, carbonate ores, once converted to their oxides, they can be reduced easily to their corresponding metals. Similarly, the sulfide ores also once converted to oxide, they can be reduced easily to their metallic form. So that is why they are converted to their oxides. You must have seen tarnished copper vessels being cleaned with lemon or tamarind juice. Explain why these source substances are effective in cleaning the vessels. Abhinav?
Because
Hmm?
tamarind juice is an acid. Tamarind and lemon.
Yeah, they are acids, and acids can react with the metal oxides. Since acids can react with metal oxides to neutralize them, and therefore we use these substances to clean them. Alright? Generally, the vessels, they may copper vessels or other vessels, they form a layer of sulfide or oxides. Copper generally forms a layer of sulfide on the surface. So to remove them, we use acids which can neutralize their sulfides and oxides. Differentiate between, okay, this you can do, I think. Just read question number 15. Read question 15. Rizwana Sheikh, you haven't answered any question. Rizwana,
Yes, sir.
yeah. Let's read question number 15 and try to answer.
Sir.
Read question 15 and try to answer.
Okay.
See, a man went door to door, watching a goldsmith. He promised to bring back the glitter of gold, glitter of old and dull gold ornaments. An unsuspecting lady gave a set of gold bangles to him, which he dipped in it, a particular solution. The bangles sparkled like a new, but their weight was reduced drastically. The lady was upset, but after a futile argument, the man beat a hasty retreat. Can you play the detective to find out the nature of the solution he had?
It is aqua regia.
Yeah, he had aqua regia, which can
Sir,
dissolve gold.
acidic.
No, it's not an acidic solution. It's aqua regia. We have studied about aqua regia here in the class. Aqua regia, it is a solution which is formed by taking concentrated sulfuric acid and nitric acid in the ratio 1:3. Sorry,
3:1.
3:1. It's the ratio 3:1. Okay. So, if you take only concentrated sulfuric acid, it can't dissolve gold. If you take only concentrated nitric acid, it also can't dissolve gold. Right? But if you take combined this one, then it can take up gold. Then if you take this in aqua regia, which is a solution of this, then you can get it. Okay. Last one, question 16. Give reasons why copper is used to make hot water tanks and not steel, an alloy of iron. Yeah, why copper is used to make hot water tanks and not steel?
Sir, isn't steel also used?
Generally, we use copper. See, as steel is an alloy of iron, so it can corrode easily. Whereas corrosion of copper is not possible. So that is why we use copper and not steel. Steel gets corroded easily. Okay, one more question from this topic. A nail made up of iron, it gets corroded or rusted when dipped in water. Why doesn't a ship get corroded?
Can you repeat it again?
Huh?
Can you repeat it again?
See, if you take an iron nail and dip it in water, so iron nail gets corroded. But if you take the ship which is made up of iron, it's all every time in water. Why it doesn't get corroded? Why the ship doesn't get corroded? And it's there in salty water also. Yes, why it doesn't get corroded, whereas an iron nail gets corroded. So think of these things.
Is it due to the hardness of the water?
Yeah?
Is it due to the hardness of the water?
No. If you put in hard water, then also it will corrode. It will find rust over there.
Or is
Alright.
it because
So
of the
think
salt?
over this. We have done these questions from this chapter. Just go through question and answers of this chapter. We will be discussing a few more questions in the next class. Okay, are people able to see the screen?
Yes, sir.
Okay. So let's try some more questions if it's possible. I'll show you some more questions. And after this, we'll be completing. I think we are left with only carbon and its compounds. Yes? Is it only carbon and compounds that we are left with?
Yes, sir.
Just 1 minute, I'm resharing.
Sir, when does this class end?
Yeah. Next
When does
class is, I think, day after tomorrow.
Okay, sir. When does this class end?
This class will just end in 2-3 minutes. I'm sharing the question paper. You just have a look, and then I'll share the question paper through the group also. I'm just waiting for this. Just give me 1 minute. I'm just showing you the questions over here. If possible, we'll try to discuss a few questions. Mm. So it will take time to do search them. Okay, all right. If I search them, I'll just send it in the group. Try to do those questions. All right. Okay. Bye, all of you.
Thank
See you
you,
again
sir.
in next class.
Thank you, sir.
Thank you, sir. Bye, sir.
Bye, sir.
Bye.